Hello, my name is Aisa De Vries, and I'm doing this presentation on the field of optics. So what is optics? Optics is the branch of physics that deals primarily with the behavior and properties of light, notably including the interactions with matter and the instruments that we use to detect it. And this usually deals with the visible light spectra in our daily lives. And as a species that relies heavily upon our eyesight and things that we can see, the study of optics has a profound impact on our understanding of our own vision and the world around us as a whole. Advancements in human eye understanding, glasses are a notable invention as a result of our understanding of eyesight. And this has led to photography and sensors in iPhone cameras, or cameras in general, smartphone cameras, as well as atmospheric optics, which includes space telescopes and space imaging. Important physicists in the field of optics are Ibn al-Haytham, Sir Isaac Newton, and Christian Huygens. The first notable physicist in the field of optics that I wanted to discuss was Ibn al-Haytham. He was a Muslim mathematician, astronomer, and a physicist of the Islamic Golden Age, and he is referred to as the father of modern optics. In this experiment, he discovered that the human eye functions much in the same way that his experiment did, and ultimately he determined that light bounced off objects outside and traveled through a hole in the wall of his room and made the image on whatever sheet of paper, as you can see here. Discoveries and impact of Ibn al-Haytham. He has had lasting impact on the study of optics as well as the field of science as a whole. He was highly regarded for his utilization of the scientific method. His notable contributions are the Book of Optics, notable for his idea that light enters the eye rather than the eye emitting light. Sir Isaac Newton is the next notable physicist and philosopher that I wanted to discuss. He is universally recognized for his major contributions to optics, calculus, and celestial mechanics, as well as physics as a whole. His notable theory is the corpuscular theory of light, which basically states that he believed that light was made up of individual particles known as corpuscles, and this theory was later proven incorrect as it failed to explain accurately diffraction as well as interference and polarization. And he faced major opposition from Huygens, another prominent physicist near his time. And in this experiment, which focused around the bending of light through prisms, led to the discovery of the light spectra through white light. And the math for Newton's prism experiment is basically attributed to Snell's law, which states the following, as well as n sub f is equivalent to the refraction index. And white light is made up of all different wavelengths of light, as not all light has the same frequency. It creates the different colors, and each energy of light is given by the equation E equals h times v. This results in each light refracting differently, creating the splitting of colors in his prism experiment. Discovers an impact of Isaac Newton. As per usual, with his work has resulted in numerous advancements throughout the field, and notably his book Optics serves as the documentation of his studies with light specifically, and his theory of corpuscular light, although not entirely correct, served as a basis for new light theories and other light ideas. Christian Huygens is the next notable physicist who I wanted to discuss. He was a Dutch physicist who lived from 1629 to 1695. He was a mathematician, astronomer, and inventor, and this was during the period of great scientific advancement throughout Europe. He is notable for his contributions to optics and his wave light theory. He challenged Isaac Newton's corpuscular theory directly. Christian Huygens, unlike Isaac Newton, was attempting to answer the question of how light travels, as well as what it is made out of. In his opinion, unlike Newton's theory of corpuscular light, he believed that light travels in waves rather than particles, and this became known as his light wavelet model. Huygens' model could explain both diffraction and interference of light. It discovers an impact, as I just discussed. Christian Huygens contributed much to the field of optics, coming up with the Huygens principle, which essentially elaborates upon his own wavelet theory. His greatest impact was challenging Isaac Newton and driving the light debate forward. Huygens versus Newton, perhaps the most notable event that occurred during their respective theories on light composition, was their sort of rivalry between Isaac Newton and Christian Huygens. Left Huygens and right Isaac Newton. They both fought one another in the attempt to accurately determine how light travels. And at the time, it appeared that Isaac Newton, here on the right, won this debate. But over time, as more research was done, it was revealed that Isaac Newton's corpuscular theory is incorrect, while While still not entirely correct, Christian Huygens was more correct in his ideal that light traveled in a wave-like motion. Lasting impact in the field of optics. Al-Haytham's Book of Optics has led the field as well as serving as guidance for how science is to be done since its inception, as he used the scientific method. Huygens and Isaac Newton's research into the composition of light and how it travels pioneered the way for the future research into optics and modern optics research, fiber optic cables, which works with bandwidth and high-speed internet, LiDAR, which is notably used for autonomous vehicles. These are the references, and yeah, that's it. Thank you.